So I'm going to talk about a couple of research projects we've been doing over the last couple of years, trying to introduce some gamification into cognitive research. So I'm going to tell you about two studies we've got running with using online games of quite different sorts, using quite different approaches to gamification. One using Gorilla Gamebuilder, which is new and shiny, and one using the Animal-AI environment, which is a sort of home-built thing that I'll tell you a little bit more about. Just a caveat before I start, I am not an expert on online research by any means or gamification. I'm just sharing some current research that we're doing, but I'm hoping that not only there might be some useful things for other people in here, but also maybe we can get some help from some of you guys. So the thing that I started off thinking with trying to gamify is that we need to meet kids. When we're talking about trying to do research with kids, we need to meet kids where they already are. Kids are playing computer games if they were allowed to get away with it all day, every day. If we want kids to engage with our research tasks, we can learn a lot from what they are spontaneously choosing to do with their time already. And so the first kind of subset I'm going to talk about is what I've called tablet tots. That is to say, very small children. And we're used to researching with very small children in the lab, because there's lots of reason, with kind of physical handleable tasks, because up until very recently, this is not a group, we're talking sort of 1 to 5 year olds. This is not a group that we can usually easily do computer tasks with. But with the advent of tablets, we now have, and proper tablets that they have at home all the time, not the old fashioned kind. We now have an opportunity to really exploit the kind of experience that young children now have. And again, I'm speaking here as a parent of small children. These are my two small children here, aged 2 and 4 in that picture, playing on their tablets, who would, if allowed, play tablets all day long. And what we can learn as a parent from just watching this is that there's a few things that, particularly for the younger kids, seem to be quite reassuring as would-be game developers. Firstly, these games are not sophisticated. They don't need a clever backstory. They don't need anything really fancy. Young children, 2, 3, 4 year olds have very simple tastes. Repetitive is fine. Repetitive is good. They like repetitive. They can't read. So many games on the tablets, let alone so many experiments, have text instructions. You need to have audio instructions. They will click on the most obvious thing on the screen, and they don't know gaming and internet conventions. If you have a symbol that universally means something, unless it's literally the play symbol with a triangle, they don't know what it means. And dexterity, for the young kids particularly, the dexterity isn't great. So dragging and dropping is fine for like 3.5 up, but my 2-year-old quite struggles with it. So I wanted to create a game that might allow us, particularly during the pandemic, to start testing really little kids online. And I came to Joe, or Gorilla generally, with my needs in that I cannot code, I have very little time, and I have very few resources. And Joe said, well, we've got this new thing. It's Gorilla Gamebuilder. And I promise you they're not paying me. But this was quite a find. So with Gorilla Gamebuilder, I'm sure that you're going to be taken through it in more detail, but basically you get a sort of screen like this, where you can, you pick create with Gamebuilder here, and then you build a screen with objects in the screen. You can move them around and create them clickable and so on. And then you have lots of different pages on the experiment, but then you can also animate to change the nature of what's on the screen as people go through the task. So I wanted to start very simple because I didn't know what I was doing. So I created a very simple visual search task. So this task, the pirate game, is a very simple visual search task. Essentially, you get given a target item. So you get the pirate and they say, please, can you find this? So this is a silver coin. And then after that, you get an array. So this is an example of a pop-out array. That is to say that the target is different from notably different from the distractors. And so the idea is that this would sort of pop out at you. Or you can have what I've referred to as a camo array, which is where the items themselves don't stand out terribly well from the background and are quite similar to one another, and this involves much more search effort. So what we varied here was set size, i.e. the number of distractors, the obviousness of the target, and the position. So I'm just going to show you a quick little video of what this task looks like. If someone could tell me whether or not the sound works on this, that would be really great. Could you hear that?
The sound isn't coming through to us.
Okay, the sound, the only thing with the sound is that all of the instructions are also read out as well as being
Lovely. That's such a nice thing to do for young kids.
So it says, can you find this? And then you have an array, and the child has to go and tap or click on the target. So these are the practice trials, and these are all nice, big, obvious targets. Let's get. So that's the end of the practice session, and then we have more trials, but just with much more varied stimuli. So these are kind of slightly obvious examples, and then you have these ones that are the really difficult ones. Okay. So that's the game. It's incredibly simple, and actually the gamification isn't great either in terms of my design, because we didn't do much in terms of like cool animations that happen when you get the right answer and so forth. And that was mostly because I was so short of time. I designed a whole animation to do, but I didn't have time to do it. But it's totally doable with the system. So I'm just going to show you a little bit about the kind of data quality and stuff of the data we've got so far. This is work in progress. We've so far only got 9 4 to 7-year-olds and 16 8 to 12-year-olds. This is, as Joe mentioned, a study on cognition in kids with long COVID, where we're testing those who have had COVID and those who have not had COVID. If you have a child aged 4 to 12, please feel free to sign up. We are still recruiting. You can just follow that QR code to do so, and I'll be at the end of the talk as well. So with it bearing in mind that this is work in progress, and I'm not going to show you the COVID, non-COVID data because the sample is too small for that so far. But what I wanted to check was to whether or not this was showing the right sort of patterns that we'd expect to see with a visual search task. So you can see here, this is you've got children, different age groups, and the performance in terms of reaction time and accuracy across these different levels of difficulty. So here we can see that, as you might expect, the more obvious the target, the quicker kids are and the more accurate. And that's actually with the older kids, performance reaction time remained pretty steady, depending on how many distractors there were, but the younger children, that went up quite significantly. And this is what we were really looking for, this effect of the interaction between set size and pop out, which is something you really expect to see with a visual search task. So here we can see that when the target is obvious in the pop out condition, you see this flat reaction time. Whereas in the camo condition, when the item is quite subtly different from the distractors, you get an increase in reaction time as the set size increases. And that suggests we're picking up on the two kinds of visual search, the pop out effect where you just see it, and the serial, having to look at every single item in turn sort of effect. And that's really reassuring. The other thing I was looking for was a left-hand bias. We tend to have a left-hand bias in visual search, mostly because in English we read from left to right, and also because of the left-hand, right-hand brain issue that we're both mostly right-handed. And again, because I was able to dictate exactly where on the screen each of these coins were, and they each had a location, I can then map that. And I found that I've got this nice central to left-hand sided bias. So that was just an example of the first go I've had at doing things in Gamebuilder. I made a functional visual search task in about 2 weeks with no coding. We can put audio instructions on so the little kids don't have to read. It's playable on tablets, laptops, computers, and phones, but I opted out of that. And it was by far the most popular of all the tasks that were in that larger study that was part in. I'll definitely be making more tasks this way. And with more time, I think I can make something a lot better. But that's what I could make in less than 2 weeks, the time I had spare in 2 weeks, which I think says a lot. The other thing I'm going to talk to you through is the other kind of set of research that I've been doing in the last couple of years. And this is potentially for slightly older kids. Some cognitive abilities don't really lend themselves to be tested on this sort of 2D Tapler's style game that I've just showed you. These are better tested with games using embodiment or some form of embodiment, where you are a first-person individual exploring an environment, interacting with objects. And these are really popular with kids, as we can see with the popularity of games such as Minecraft and Fortnite. They're normally first-person shooters, but you don't actually, there's no law that says you have to have a gun in the game. So I want to introduce you to the Animal-AI environment. This is an environment created by a research team that I work with, created in Unity and originally designed to assess cognition in AI using tasks that are designed for testing cognition in animals, and that can be or have been physically implemented with animals and small children in real life. So to see kind of a little bit what it looks like, the aim of the game is to collect these green balls or yellow balls as well. So it's very simple aims: retrieve food, which are green or yellow balls, avoid poison, which are red balls, and avoid lava, which is a red or orange floor. And so we did a kind of a proof of concept study looking at comparing deep reinforcement learning AIs and 6 to 10-year-old children on a subset of the tasks that we presented in a competition, an AI competition a couple of years ago. There were 900 tasks in the original competition. Kids can't do it, 900 tasks. So we chose 40 tasks from 10 domains that kind of span the kind of simplest, kind of common sense kind of cognitive tasks that people do with animals. And this is Cozy Voudouris, who is my PhD student who did this work. So how do AIs compare to 6 to 10-year-olds? Well, a summary of the data is not well. Children outperformed AIs on everything. There was no significant difference between the age groups, but interestingly, experience with similar computer games did make a difference to the results. So that's just a thing to note, that if you are gamifying in a way that matches something kids might be doing, then they will have some expertise that will differentiate between different children. And Cozy did a cluster analysis showing that you could identify which individuals were AIs and which were children, regardless of the age of the child or the flavor of the AI. One thing we looked at particularly, for example, was object permanence. This is something that kids past the age of about 12 months in real life scenarios. We saw that with the agents, we could see that we can watch what they did. So not only look at their score, but watch what they did. And if you look back, not only do we know that, for example, the top agent only scored 25%, we know that they got that score by using the rule, always go left. And so actually, if we compared children to even the best AIs, children outperformed them on every single thing. There were one set of things that, for example, the children didn't do so well on. This is an example of a tool use task, and this is a 9-year-old who passed it. And we realized afterwards, and this is one of the importance of kind of doing these proof of concept and preliminary stuff, that these were just way too difficult. It sounds obvious to pull a hook to get a reward, but actually the physical manipulation of the hook was actually very difficult for children and AIs both. But what was interesting is that the difference between the children and the AIs was completely observable, even when both failed. So you can see it here on the left, an AI basically just going around in circles, whereas the child takes a really considered approach. We can watch back exactly what the child did. And then through different ways of coding the data, we can start to get maps of not just performance, but of pattern of performance and type of behavior. We're taking this forward with the Animal-AI environment. Firstly, I'm working on some particularly large batteries. So Cozy's working on an object permanence battery, and this is Denaya, who's working on a space and object hood battery. We're also working on new features. So we're building in reward dispensers, which are these, ripening and decaying rewards, and new playable characters to make it cuter and funner. So we're basically trying to make it more versatile and attractive. It is currently available for other researchers to use online, but it's really tricky and fiddly at the moment. So we're trying to work on making it more available as well. And so to this end, we will be hiring someone. So please do watch this space. And if you've got game dev experience, particularly with Unity and putting things online, get in touch. And the point of this, I realize I'm running out of time, that the point of this particular approach is that we're really trying to build this for translational potential. The Animal-AI tasks are designed to be, because they're in this kind of physical environment that could be real, it could be a room in a lab. They are playable as computer games, yes, but they are directly related to those tasks that can and are used physically in the lab, both with animals and children. So this facilitates translation between animal models, lab work with babies, toddlers, children too young for computers, online games for older kids and adults, and computational models, because remember, this was designed for and is being used for assessing AI models. So we can make computational models of cognition, of impairment, of development, and directly test theoretical accounts, all within the same environment. So to summarize, Einstein apparently said that having fun is the best way to learn. Having fun is, I think, also the best way to test what has been learnt. And I'm certainly going to be moving more towards gamification in everything I do from now on. So just a quick thank you to the many people that have been involved in both of those research projects. And thank you to Gorilla and to Joe for inviting me to speak today. If you want to take part in want to try out the pirate game on your own kid, you can follow this link down here at the bottom here, or scan this QR code and it'll take you to the recruitment site. Thank you very much.
Thank you, Lucy. That was amazing. I'm going to ask the audience in the chat to put any questions you have for Lucy into the Q&A now, so that I can come back to those in a minute. I'm just trying to think what I want to ask you. I actually just find that also fascinating. What I don't understand is, how have you been able to do all of this? You're like a mum, you've got 2 kids about the same age as mine. Okay, so I did the visual search task, and that was mostly because with the COVID project, it's funny, I have 2 hats on. I am a researcher in the psychology department doing the effect of kind of health on memory and cognition, and that basically has no funding and is running on volunteers and students and like me trying to do stuff myself. And then I'm also I work in an AI institute called the Centre for the Future of Intelligence, and there I'm the director of the Kinds of Intelligence project, and we've got multiple incredibly talented postdocs doing amazing things and PhD students as well. So I like that. This is well resourced, this is not. So on this side, I did the game builder thing myself because I didn't think it was fair to expect anyone else to kind of work out this new tool. There is a moth on my face. And with the Animal-AI thing that's being developed it's mostly funded by people who are very interested in understanding the cognitive abilities of AIs at the moment, which is a big deal for for economic, policy, security, and so forth reasons. But I'm keeping it so that it can still test kids, so that we can bring it more further into psychology. And I'd really love to build a community around people using this to test kids, because I think it has loads of potential. But yeah, there's a big team. So that's amazing. I totally agree with you. I think the idea that AIs are going to reach adult level cognition without first developing childlike cognition is unlikely, and the data
they need rat-like cognition
first, right? Yeah, and so we're going to have to work this way back and layer them in. And that was so interesting to see how the AIs were performing against, what was it, 6-year-olds?
6 to 10-year-olds,
6 to 10-year-olds, and still very basic. But if we can get that data from younger children, that's going to help that journey. But of course, at the moment, you can't get younger children to do this task online. They're too complicated. But if we can simplify them, then we might be able to start getting to a point where the AI can outperform a very young child, if we're confident they're using the controls. So I think that's tremendously interesting. A question has come in. Thank you. Do you ever allow adults to play with their kids, e.g. as a fun activity to do together? Because then adults could try to encourage kids to beat them.
That's a good point. It's a good idea. We haven't done that. With the pirate game, I'm not sure how. I mean, yeah, there's the practice trials and so on. But I think with Game Builder, you probably could. Yeah. With Animal-AI, certainly, like we had practice trials, and it's very open, which is why it takes actually a lot of skill and developer time. So it's currently tricky. But we had in the study that we ran, we had children requesting to be able to come back and just keep playing and messing around with it. And so we had to kind of have a 2-tier system, like we're collecting data from you versus like you've come back for the 16th time and are trying to beat your own record. So definitely there was lots of scope for that. And the tasks we were doing were boring for adults, but that's because it was really like, here's a reward, can you get it? But they don't need to be boring for adults, and we've made some really hard ones now. So hopefully we should be, when we are planning on testing adults as well. So I think that's a really great idea of way of engaging kids.
Yeah, and if you were using Gorilla Gamebuilder, there are two ways you could do that. You could have like, now the grown-up has a go and now the child has a go. So you could interleave them. That could work really well. Or we do have multiplayer coming to Gorilla. So you could set up so that a parent and a child could in fact play together and respond to the same task. I guess the bit that's always tricky there is you don't want the parents coaching the child, because you actually want to genuinely capture the child's behavior. That's always the tricky bit to compensate for. I hope I have tweeted your link that you need more participants. If anybody on the call today has got young children, please do consider reaching out to Lucy